Okay, guys, example number 3 now. Pretty easy here. It says x squared minus 10x plus 14. Well, this is kind of like what we just did. And I may talk about a little something else when we get to the end of this. But it says it wants us to factor it, and there's nothing in front of the x squared, so I know it's going to be x times x. The question is, what goes here and here? Okay, well, let's take 14, all right? And I need to factor it, but here we go, guys. This one's negative. So I know I need some negatives, but since the last number is positive, I know they have to both be negatives, okay? Because only if I multiply two negatives do I get a positive. All right, so let's factor this thing. I know it can be negative 1, negative 14. It can be negative 2 and negative 7. It can be, whoa, that looks like it. Okay, all right, so let's add them together. If I add these two together, I get negative 15. If I add these two together, I get negative 9, and I'm looking for negative 10. Whoa, I wonder what that means. What does that mean, Jordan?
That means that it just stays.
That means that it's prime. Thank you very much for listening to the introduction. That's right. If I can't break things into two factors, then that means that we would say that it is prime, and it can't be factored. Now, let me ask you this, Winslow. Even if I can't factor it, could I use the quadratic formula and find the solutions to this, if there are any? I can. They just wouldn't be whole numbers, right? Because a number like 30, well, let's see, 37. 37 is a prime number. Yes? That means it has no factors other than 1 and 37. That doesn't mean I can't break it down into 2 times 18.5. Right? It's just they're not whole numbers. This can be solved, right? I can find out what x equals. They're just not going to be whole numbers, right? This thing is prime. So we can't factor it into two binomials. We just leave it as the quadratic. Okay? Excellent job, gentlemen. And let's see you at example number 4.